All right, so we are going to get started with example 2, indirect measurement applications. So indirect measurements, what those are, that is a method of measurement where a proportion involving similar triangles to find a length that is not easily measured. So what we're actually going to be doing is using the sun and the shadows that the sun has on particular figures to find heights of figures that may be too tall for us to measure directly. So we're going to measure it indirectly. So if you look at this picture right here, this is a totem pole, and I know you guys are super impressed by my drawing. You know, I put some little extra effort into it just for you guys. So we don't know the height of the totem pole, but we know the height, how long the shadow is. And then here's a person, and we can measure that person's height and their shadow. And so using all of this information, we can actually come up with similar triangles. And so this side of the triangle is X, that's the height of the totem pole. The shadow would be 45. And then here, this is the person's height, which is 6, and then their shadow right here is 3. And so these triangles, due to the sun, are similar, and then we can set them up as a proportion like we were doing in the last example to figure out what X is. So it says a totem pole casts a shadow that is 45 feet long at the same time that a 6-foot tall man casts a shadow that is 3 feet long. Write and solve a proportion to find the heights of the totem pole. Okay, so what we have similar triangles here. And so we need to just figure out what those corresponding sides are. So let's look here. I would say the first corresponding side is right here with X and 6. So we're just going to go X over 6 is equal to the other set of corresponding sides, which would be right here, 45 over 3. 45 over 3. And so the biggest thing, we have our corresponding sides, but you just want to make sure that this triangle's information is on the top of the fraction. So X and 45 both come from this triangle, which is good. And then 6 and 3 come from this smaller triangle, and so that information needs to be on the bottom. Okay, so as long as you did that, you're going to be fine. So from here, we're going to just figure out what X is. So we could do the cross products property, or we could just multiply both sides by 6. Okay, and then, you know, these 6 they cancel out, and we're left with X. And then we just need to cross cancel, right? So is 3 and 6, do they have a common factor? They do. Right? It's 3. 3 goes into 3 one time. 3 goes into 6 2 times. And then we just multiply across. 45 times 2 is 90. And 1 times 1 is just 1. 90 over 1 is the same thing as 90. So that means that the totem pole is 90 feet tall. So there we go. All right, let's go ahead and try B. It says a forest ranger who is 150 centimeters tall casts a shadow 45 centimeters long. So we have a forest ranger here that is 150 centimeters tall and casts a shadow. I always like to draw pictures, it helps. 45. So that means that our triangle is going to look something with just the numbers. Like this would obviously be a lot smaller if it was proportionate to 150, but don't worry about that. We know there's similar triangles. I'm just trying to just draw the triangle and put some numbers on it so we can tell which sides are corresponding sides. Okay, so a forest ranger who is 150 centimeters tall casts a shadow which is 45 centimeters long. All right, good. At the same time, a nearby tree, okay, so we have a tree here, and casts a shadow that is 195 centimeters long. Write and solve a proportion to find the height of the tree. So we don't know the height of the tree, so that's going to be our X. Okay, so the triangle over here is X is going to be here, and then 195 is going to be on the bottom. So we're just going to set up those corresponding sides, right? And And actually this time I think I'm going to put this triangle on top of the fraction, so it's going to be x over 150 is equal to, the other corresponding sides would be right here. So we're putting the x triangle on top, so that means 195 also needs to go on top, over 45, okay? Then I just want to get x by itself, and I could do the cross products property, or I could just multiply both sides by 150. I think that's what I'll do. This 150 and this 150 are going to cancel out. And then we can do some cross canceling here. So what I'm going to say is that I think 15 goes into both of these. 15 goes into 45 3 times, and 15 goes into 150 10 times. Then from there, I'm going to see if 195 is divisible by 3, because you can't read, there's no common factor between 3 and 10. So what about 3 and 195? So if I add up these digits, 1 plus 9 is 10, 10 plus 5 is 15, and 15 is divisible by 3. That means this whole number is divisible by 3. So I'm going to go over here and just do some quick long division to see 195 divided by 3. So 3 doesn't go into 1, but it goes into 19 6 times. 6 times 3 is 18. Subtract, drop down the 5. 3 goes into 15 5 times. So that means 3 goes into itself 1 time, and then 3 goes into 195 65 times. And then we just go 65 times 10, which you just add a 0 on the end, so 650 centimeters. That is the answer. All right, perfect. Let's go ahead and look at the next example. So what do we have? We have a woman who is, give her a nice little hairdo, 5.5 feet tall and casts a shadow that is 3.5 feet. At the same time, a building casts a shadow that is 28 feet long. Write in solver proportion to find the height of the building. We don't know that. That's going to be our x. So if we draw our triangles, we have 5.5 here, 3.5 here, x, and 28. And we want to just go ahead and set up these corresponding sides. I think I'm going to put this one on top. So x over 5.5 equals, the other set of corresponding sides would be right here. And the x triangle's on top. That means that 28 needs to be on top here. And then 3.5 there. And then again, we just want to get x by itself. So I'm going to multiply both sides by 5.5. Okay, these cancel out. I'm left with x. And then I just need to do the math right here. So 28 times 5.5. 5 times 8 is 40. 5 times 2 is 10, plus 4 is 14. And then we put a 0 in the 10 spot. 5 times 8 is 40. Write the 0, carry the 4. 5 times 2 is 10, plus 4 is 14. And then we just add. Okay, so we get 1,540 divided by 3.5. Okay, so we need to go over here and do that. And the one thing you have to remember is whenever you're dividing by decimals is that you can never divide by decimals. So we need to get rid of the decimal by moving this over to one place, making it 35. And if we move this place over 1, we have to move this place over 1 as well and put a 0 there. Okay, so we're looking at 35. Can 35 go into 1? No. Can 35 go into 5? 15? No. Can 35 go into 154? Yes. And I'm going to say it goes in 4 times. Okay, so we put that on top of the 4. 4 times 5 is 20. Write the 0, carry the 2. 4 times 3 is 12. Plus 2 is 14. Then we subtract. Drop down this 0. Oh, and we already know that 4 times 35 is 140, so that means 35 goes into 140 4 times. And then we know that 4 times 35 is just 140. So we subtract, there's no remainder. We bring this 0 down. 35 doesn't go into 0, it goes in 0 times. And there we have our answer right there. X equals 440, and what are we talking about? Feet. That is how tall the building is. That is a tall building. All right, so I want to give you a chance to work on these problems on your own and see if you can do it using the indirect measurement. So I want you to work on D and E. Go ahead and draw yourself a picture. Make sure you write your proportion and then show all of your wonderful mathematical work. Okay, so go ahead. There's my friend, the pause dragon, reminding you to pause your device. When you get done, press play and we'll go through both examples. All right, see you in a bit. See you in a bit. Okay, let's get started. Let's see how you did. A flagpole casts a shadow that is 75 feet long. At the same time, a 6-foot tall man casts a shadow that is 9 feet tall. Okay, so I have a flagpole. There's my lovely flag. It's an okay flag. Now it's just getting worse the more it's just going to be blue. It's all blue. It's a blue flag. Okay. What do we know? A flagpole casts a shadow. So it casts a shadow that is 75 feet long. At the same time, a 6-foot tall man casts a shadow that is 9 feet long. Oh. 9 feet. All right. I'm just going to go ahead and draw, what does it say? Write and solve a proportion to find the height of the flagpole. So we don't know that. That's our X. I'm going to go ahead and draw my 2 triangles, 75 and X, and 6 and 9. And then we're just going to go ahead and figure out what those corresponding sides are, right? The heights. And do the proportions. So I'm going to go X over 6 is equal to, the other set of corresponding sides would be right here, 75 and 9. Just got to make sure we're dealing with this triangle, so the 75, the X is on top, which means the 75 also has to go on top. And then over 9. Okay, and then I think what I'm going to do is to get X by itself is just multiply both sides by 6. Those cancel. I'm left with X equals, and then I'm going to cross cancel here. I would say that there's a common factor of 3. 3 goes into 9 3 times. 3 goes into 6 2 times. Okay, so I can't cancel anymore there, but can I cancel here? Let's see, 7 plus 5. Let's see if this 75 is divisible by 3. 7 plus 5 is 12. 12 is divisible by 3, so that means 75 is divisible by 3. So 3 goes into 75. I think it goes in 25 times, like 3/4 is 75. So yeah, 3 goes into 75 25 times, and 3 goes into itself 1 time. And then we just multiply across. 25 times 2 is 50, and then we just have 1 and 1 on the bottom. 50 over 1 is just 50. So there we have it. X equals the height of the flagpole is 50 feet. So if you got 50, awesome job. Let's go ahead and see how you did on E. It says a tower, okay, so we have a tower, casts a shadow that is 450 feet. At the same time, a 4-foot child casts a shadow, a 6-foot shadow. Write and solve in a proportion to find the height of the tower. Maybe I'll just make this a tower. I don't know. Anyways, the height of a tower, we've got to figure that out. So I'm going to make my triangles. X and 450 and 4 and 6. And then we just need to make our proportions. So set up our corresponding sides here. I'm going to put X over 4 is equal to, so we have to have the same triangle. So if X is on top, that means that 450 has to go on top of the fraction, and then 6 goes on the bottom. And we want to figure out what x is, so we're going to just multiply both sides by 4. And these 4's cancel out. We're left with x, and then we just want to cancel. See if we can do some cross-canceling first when we're multiplying fractions. So is there a common factor between 4 and 6? Yes, 2. 2 goes into 4 2 times. 2 goes into 6 3 times. So I can't reduce that, but can I reduce this? Yes. Let's see here. So we need to see if 450 is divisible by 3. If we count up the digits, 4 plus 5 is 9 plus 0 is 9, and 9 is divisible by 3. That means 450 is divisible by 3. I don't know how many times. I'm going to have to figure it out. 3 goes into 4 one time. 1 times 3 is 3. 4 take away 3 is 1. We drop down the 5. 3 goes into 15 5 times. 5 times 3 is 15. There's no remainder. We drop down this 0. 3 does not go into 0. It goes in 0 times. So there we have our answer. 3 goes into 450 times, and 3 goes into itself 1 time. So now we just multiply across. 150 times 2 is 300, and 1 times 1 is just 1. 300 over 1 is just the same as 300, and what are we talking about? We're talking about feet. So 300 feet. That's how tall the tower is. So if you got that right, you did a great job, and we will see you next time. Goodbye.